Okay, what we're going to do today is we're going to look at graphing quadratic functions in vertex form or intercept form. There's two different ways, and these are fairly easily done by hand. So today we're going to look at the first one is in vertex form, and that's when we take our quadratic equation. It's going to look something like ay equals ax squared plus bx plus c. And we're going to turn it into an equation that looks like this. Okay, y equals x minus h squared plus k. And the reason this is handy is several. One, we know right where the vertex is. It's going to be at the specific point hk. Notice that the h is the opposite here. The other thing is that we know where our axis of symmetry is, and if we know that, all we need to use is that mirror rule to graph. We know that if a is larger than 0, that our graph is going to open up, and if a is less than 0, our graph is going to open down. Okay, so that's kind of what's going on. Well, let's look at these two guys right here. What if we graphed y equals x squared? You've seen this before. So there's your graph of y equals x squared. Notice that the vertex on this guy is 0, 0. Okay, here's my vertex, 0, 0. And what have we added to the x here? Notice we could write this as y equals 1 times x minus 0 squared plus 0. That's our vertex, our axis of symmetry, everything. We can see everything. Well, now, check out this other guy. So, what about him? Well, notice that with this guy, we've got an h and a k now. And so, our graph moves. And it's no longer centered on the origin. The vertex has changed places. And so now with h, okay, h is 2. Look, come over here to 2. Here's h right here. So we would say that h would be this distance from here to here. There's h. And then we would say that the k then would be this distance from here to here. And so here's k. And what happens is we've got h, which is going to be equal to 2, and we've got k, which is going to be equal to 4. So it's going to look something like this. This guy is your k value. This guy is your h value. And so hk then becomes this point right here at this vertex spot. So what point is that? Well, if my h is 2 and my k is 4, I just put those guys in, and I've got the point 2, 4. Okay, so this is how it's going to work, and it's going to be very easy. Don't let this be hard on graphing out of vertex form. Okay, now we're going to take these vertex form and intercept form equations and turn them into standard form quadratic equations. And what is standard form? Standard form looks like this: ax squared plus bx plus c. So we're now going to get try and eliminate these parentheses so that we just have one set of numbers that make a polynomial. It's not as bad as it sounds. A lot of you guys may remember from previous quadratic stuff that you're going to FOIL, and it's just going to be first times the outer times the inner times the last. So first terms will multiply together, outer terms will multiply together, inner terms will multiply together, and last terms will multiply together. Okay? And once you get all of this done, you will combine the things that are the same. So let's look at what's going on here. So we've got y equals -2, and then do your guys connected by red. X times x is x squared. Do your guys connected by green, that's going to be -8x. Do your guys connected by blue, that's going to be 5x. And do your guys connected by purple, and that's +5 and -8, which make -40. Now, notice inside this that we've got a couple of things that are the same. So our next step would be to combine those terms together so that we have y equals -2 times x squared minus 3x minus 40. Remember, -8 plus 5 will be -3. And then distribute your -2. You've done this before. You've seen it before. You're going to do it a lot here in the next few days. So get comfortable multiplying these guys out. The other thing that we're going to look at is from the vertex form, which is the same but different. And what we're going to look at on this guy is this part right here, this little 2 up here. What does that mean? That means that what I'm really working with is y equals 4 times x minus 1 times x minus 1 plus 9. And to do this guy, we've got to do this part first. Okay, this part needs to be done first, and after he's completed, then we can get on to adding the 9 and the multiplying with the 4. Okay, so again, just like we did on the previous problem, I want to connect these two guys together. I want to multiply these two guys together, my first and my outers. I want to multiply my inners together, and I want to multiply my last terms together. Okay, so this is the setup for this particular guy. What does that give us? It gives us y equals 4 times x squared minus x plus 1. And all I did was move the colors. So I did, here's your green. Let's see, here's green right here. Here's your blue guy right here. Here's your purple guy right here. Here's your red guy right here. So that's all we did. Combine those like terms. So here's a like term and here's a like term. And when you do that, what you're going to end up with is y equals 4 times x squared minus 2x plus 1 plus 9. Now distribute your 4 and don't forget your plus 9. So my very last step is to put together the 4 and the 9. And so that's going to be y equals 4x squared minus 8x plus 13. Okay? So here we go again, another graphing in vertex form. I've listed all the rules again for you just in case you forgot from that last example. But now we want to know, what is -1/2 x minus 3 times x plus 5? Well, notice, this is a little bit different than our previous problem. This is actually what's going to be called intercept form. So the same things need to happen. We need to find some missing things. Well, one of those things that we need to find is a. A doesn't change. It's that number in front. Here's a right here. So my a is going to be -1/2. Right off the bat, we know that we're going to open down. Okay. But now here's the interesting thing. We've got x-intercepts P and Q. X-intercepts P and Q. What does that mean? That means P and Q. And notice it's the opposite game going on here. P will be positive and Q will be positive if the x is subtracting them. So when you look at your problem on this guy, notice that right here I've got -3. So super secret opposite society inside of parentheses, okay? And what that means is P will be 3. And then x plus 5. Again, inside of parentheses, we've got the super secret opposite society, so that would be negative 5. So that's our x-intercepts. We can plot those on the graph right now. We can go to the point. We'll put the green 3 up. We'll put the blue negative 5 up. And then exactly halfway in between those two guys is my axis of symmetry. So that would be like negative 3 plus 5 divided by 2. We would just add those two numbers up, and we're going to get what? 2 over 2, which is 1. So my axis of symmetry should occur right in between those two guys. Would have helped if I would have written them down correctly. This is going to be positive 3, negative 5, which makes that a negative 1. There we go. So at negative 1, this is my axis of symmetry right here. We've got it. Okay? And that means that on both sides of this axis of symmetry, we're going to have mirror images. So let's just label a few things real quick. Let's move P. P is over here. He's my 3. Let's move Q. Q's over here. He's my 5. But this X, what is this? Well, that's for my X coordinate for my axis of symmetry. Okay? Well, what is the X coordinate for my axis of symmetry? It's negative 1. I joined everything together. Let's make it a little bigger. Okay. Well, now we just need to find the y coordinate for my vertex. If I've got a vertex here, and it's got to be somewhere on this dotted green line, if I've got a vertex, I've got my graph. And notice right here, I've got an equation. Y equals negative 1/2 times x. Well, what do I want my x to be? Negative 1 minus 3 times negative 1 plus 5. Notice this is my x coordinate in both places. And so now we can just work this math out. It's going to be not too painful. Negative 1 minus 3 is negative 4. Negative 1 plus 5 is positive 4. And so when I multiply all these things together, I'm going to get what? Negative 1/2 times negative 4, 2. 2 times 4, 8. So my vertex, when x is negative 1, y is 8. Remember, y equals, we chose x. So I put a dot right here at 8. And this is going to give me my graph. And so all you do is connect these dots. And when you connect these dots, you get this graph. Look at that. Perfect. And that's how we're going to work from intercept form.